Okay. All right. Good morning, everyone. I would like to welcome all of you to this Zoom session on Thursday, June 25th. I'm going to create a solid model for Chapter 5, Exercise 1. And also, I'm going to show you how to create mechanical drawing. Okay. Just be patient. Just watch. Okay. So we're going to start with a new, and this is Chapter 5 dash. It's not example, okay? It's exercise 1, okay? Chapter 5, exercise 1. And let me just clarify something for everyone. Make sure that when you create a folder, Chapter 5, please do not separate exercises with tutorial. What I mean by that is, do not place exercises in one folder and tutorials in another folder within the folder called Chapter 5. Please do not do that. I saw some students did it. That's very, very challenging. It's not a good idea to have the Chapter 5 assignments, both tutorials and exercises, okay? And drawing for tutorials and exercises should be on one folder called Chapter 5. Do not break it into 2 or 3 or 4 separate subfolders. Illegal move. The reason is because if you put the drawing on one folder and the solid models in another folder, these 2 folders are 2 independent folders, and the link is missing. So when the link is missing and the solid model must communicate with the drawing, mechanical drawing, that causes a problem, big problem. That means I won't be able to open it. I hope if those of you are here and those of you that will be watching this video will be clear, okay? Because I saw that 1 or 2 students did that. That was really bad, okay? Not a good idea. Okay, great. I just wanted to clarify that. All right, let's just work on this one here. We're going to start with the extrude, okay, extrude. And we're going to click on the front datum plane, okay? To sketch this, we're going to click on front datum plane, sketch view. The preparation, everybody knows how to do that, the preparation, okay? And then I'm going to put a center line in here. And again, as usual, I'm going to create a rectangle. I'm going to stretch it and make it symmetrical. And I'm going to give a total dimension of 95, okay? 95, I'm going to place it here, 95. And then the height is 12, okay? The height is 12. We're going to place it in there. So that's a base feature, 95, 12. And there is a chamfer in here. You can just place the chamfer okay, we call it chamfer, on the sketch, or you can always create that on the solid models, okay? But if you wanted to do that in here, make sure you always pick this chamfer trim, like a fillet, you just say circular trim. For chamfer, you also say chamfer trim, okay? So I'm going to create a chamfer from this corner, or from this line to this line. That's not a good idea, okay? That's not a good idea. Let me just undo that. I'm not gonna use chamfer here because it's not gonna work, because it has to start from the corner. So I'm gonna draw a line, okay? It is a chamfer, but I'm just drawing the line, and I'm going to give an angle here, which is 64 degrees, okay, 64. And I'm going to trim, okay? So I created a line from this corner to somewhere here, and I'm going to trim that line. So now I should have a total dimension, okay? See that because the symmetric disappear, I'm going to replace the symmetric, okay? On a constraint called symmetric, and then with the y-axis, so you're gonna bring the symmetric back. And if I wanted to put the dimension on this side, I will say from here to here, and that's 12, okay? So this is the base feature. All the dimensions are a strong dimension. okay, strong dimension, and ready to be extruded. Okay, the amount of extrude is, this extrude is 24. Okay, the amount of extrude is 24. So we're gonna give a measurement or dimension of, 24. Okay. So that will be 24, enter. So you hold the middle mouse button. This is the front view, that's the top view, that's the right side view. So we have completed the base feature. Now, in order to create the second feature, I'm going to create a datum plane. Okay, I'm going to have a datum plane on this face here. That is the reference surface here. And we're going to give it offset translation of 22 units. Why is 22 units? Because there is a distance from the center of the hole to the edge is 34. 34 minus 12 for the thickness that we have. It says 24. So half of that will be 12. 34 minus 12 is 22. So we say yes. So that is our plane that is located 22 units away from this surface, okay? It's offset from this surface here, from that surface. Okay, there we go. Now that we have that DTM1, I call that datum plane DTM1, and it's active. I made it active. This is green, okay? It's green, and I'm gonna say extrude. And then we say sketch view. Okay, perfect. So now I'm gonna turn off temporarily the plane. I'm gonna turn off temporarily the shade. And now we are ready to do some work, okay? All right, so I'm going to place some reference lines. So right click and click on reference, and we're going to put the reference in here and here, okay? All right, so there we go. So we're gonna start from this top here. We go up is 19 units, okay? We go up 19 units. I hope this is clear, okay? 19. And everybody see the screen nicely? Yes? Hello? Yes?
Oh, yes, Professor.
Yes.
Sorry. Yeah.
Thank you. Thank you so much. Okay, I just wanted to confirm that what I'm just focusing on this. I want to make sure everybody is seeing what I'm doing here. So
Yes, we see everything.
very good. So thank you. So this is 19, and this dimension here is 16. Okay, 16. Okay, perfect. So we have 19, we have 16, and then on the base here, we have to create a line that is 30. I think it's 36 or 38. 38, I believe. Okay, so 38. And then we're gonna go up from there, from end of that line, we go up approximate, let's see, 55, okay? So 50, 55. So there we go. So we have 55, we have 16, we have 19, we have 38. Now this line, my friend, okay, please do not worry, okay? Just create a line, okay? Not equal, okay? Just create a line at an arbitrary distance, okay? Because we don't know this dimension. Dimension for this line is not known. Just create a line and stay away from equal, okay? Do not worry. So then you select an arc. This is an arc, 3-point arc, okay? And then you go from here to there, and you can see that this is tangent, and now we're gonna give a dimension of radius of 22. And now we created a profile, and as you can see from the front view, okay? From the front view, that's the profile we want, okay? Make sure this is a tangent. This line is tangent to the curve, and everything is under control. And now we can go back to the shade, and now you see where that profile is located, okay? That profile is located at the distance, offset distance of 22 from that face. So I'm gonna click on check. Now, when we click on check, make sure you reverse the arrow, and then you give the total dimension of 68, okay, 68. Now we have this piece position on that surface, and Look at that. It looks good, correct? It looks good. So that's extrude number 2. That is extrude number 2. Everybody's okay with that? You saw what I did, correct? Everybody saw that what I did. Okay, great. Now that we have a base feature, and this is the second feature, I started from this profile, okay, that profile, and I have extruded all the way to the right, 68, okay, this is a depth. Let me just clarify something in mechanical drawing or any type of engineering, graphics, communications, or the solid model we're creating. Please remember that in US system of drafting, if we are looking at the front view, the front view has the dimension called width and the height, okay, width and height. There is no length, okay? It's not like a mathematics algebra rectangle is a length and width. Please remember that we don't use the language of length here. Okay? We say width, this is a width, and this is the height. Now, on the right side view, we have the depth. Okay, this is a depth. This is the depth, and this is the height. Okay, height, depth. So if you look at the top view, the top view has a width, and it has a depth. Okay, that's a depth. So the depth of the top view share the same measurement as the depth of the right side view. Okay, so the top view is a depth and the width. The right side view, we have a depth and the height, and on the front view, we have the width and the height. Okay, great. So that's clear. Now next. So far we have 2 extrudes, okay? Extrude number 1, extrude number 2. Also, we have created a DTM1 to be able to place this feature on that, plane, and then we could extrude it, okay? That's called auxiliary plane, okay? That's an additional datum plane to existing plane, which we call it a front, top, right. Those are the 3 existing principal planes of projection. All right, so I'm gonna go to extrude and click on this surface, okay? Click on this surface, and then we say sketch view, okay? So it's gonna come toward you. Turn off the shade for clarity temporarily. All right, so nothing is there. All right, so we have no shade. Then next, I'm going to create a center line. I'm gonna create a center line in here, and I'm going to create a circle and an arbitrary distance for time being, okay, arbitrary distance. So that distance is, if I just pick anywhere, okay, so there is a circle here, and the radius of circle is 16. Okay, let me just give the radius. You click on the circumference and you give a radius of 16. All right, there we go. And we know that the distance, if I go to, let me see, where do I want it to create a line, okay? I'm going to create a line somewhere just here, okay? It goes through the center, okay? It goes through the center. I'm gonna, I think it's supposed to go through the center, okay? Let me just do this here. No, it's not doing that. So let me just have a center line then here. Okay, and we're gonna have a solid line that goes through, okay, so we're gonna have a line that goes all the way across. Okay, great. So now that I have that solid line, I'm going to trim the lower portion here, this portion there, this piece here, this piece there, this is here, and that is there, okay? All right, so now I can give a dimension from this line here to here that should be 19, okay, 19. Okay, great. So everything is controlled by dimension. That's what we call it parametric, okay, controlled by dimension. So we have created this feature. Please do not place the hole in here now, okay? That will be last. Do not add the hole in here. So just complete this here, right there. And all you have to do is say, it's, okay. So let me go back to the shade so you can see what's going on, okay? All right, so I'm going to reverse the arrow. I'm going to reverse the arrow. See that here? Click on the arrow. It's going to be reversed. What would be the depth? The depth is going to be 16, okay? 16. All right, so the depth is 16. There we go. So I've created this feature on here with a depth of 16, and it goes all the way to here, okay? So that's a 16. This is 19, this is 16, and then we went up, then we created an arc tangent to this line here, and then we had a distance from here to here, which was 50 or 38, and then we went up 50, right? We went up 55, I'm sorry, 55. So we are done with that part. All we wanted to do is create a circle in here, okay, or a hole. So I'm gonna go extrude, and then I'm going to create a circle at the dead center, okay, dead center. Let me just turn off the, what do we call that, the shade. So remember, we don't know where the center is. So you could right click, okay, make sure you right click, and then click on reference, give a reference. And when you give a reference, you have this, say solve, close. Now that we know where the center is, so this is a concentric circle, you create a circle with the diameter of 12, and now we are ready to extrude. Okay, let me go back to shade, and now I have placed a circle on that surface. How far we should drill a hole through this material, how far, okay, is if you look at your mechanical drawing in your textbook, there's a symbol. It says how deep this hole is. The depth or how deep, you know, the symbol, it looks like a horizontal line and little arrow down. That means that's a ANSI dimensioning. American National Standard Institute dictates the symbols that we use in mechanical drawing, such as tolerancing symbols, dimensioning symbols, and trying to, you know, give notes, general notes, so that the people in the machine shop can read it, because that's a language in the United States. So we use that to communicate with the machine shop people, so they will not make any type of error or mistakes when they are making this product or creating this product. All right. So I'm going to give this diameter is 12, and how deep, we're going to just go check, make sure you reverse the arrow, and how far, we say 16, okay? 16 is a depth. So that means this hole can go on, it's a blind hole, it doesn't go all the way through. It's not a true hole, okay? And this is the complete solid model. And if I go to view, and this is the front view, okay? If I use the front view, that's the front view, and then control, maybe that. Okay, so that's the front view, and the top view is, let me see if I make it green. So control, and this is a little bit from there also, you see. And then the right side view, we have blue maybe here, and control here. And also we have the green on here, all right? So, because you see that from the top view. And then we have the chamfer here, okay? Maybe we can just use this color here to say that's the chamfer. Okay, great. Now,
Hey, Professor, I have a question.
Yes.
I was just wondering why the hole is done in a second step instead of being extruded at the same time as the circle.
In some situation here, if we would have, because we are extruding this, okay, let me just do that in here. In case, okay, so this is, I'm gonna delete that. All right, so I'm gonna delete it. And if I go back and extrude number 3, if I edit that, placement, edit, and then go back to a sketch, and then if you place the hole in here, okay, hole, in case the hole was all the way through, if the hole was all the way through, then because this piece would not go all the way through, so there will be a conflict, okay? But in this,
Right.
in this case is okay, But in case if the design intent or criteria for design or the rules changed and they said, no, that hole should be through, then you have you have a separate, extrude so that you can fix that. Okay, you can fix
Okay.
it. So,
Yeah, that makes sense.
okay, that makes sense. So
Yes, thank you.
You're welcome. If we're talking about the future design, that you are designing something, maybe you're not sure whether this hole and this feature here, they all have the same depth. Okay, so let me just do this. Let me see what will happen. Okay, let me just do what happened. There was a reason for doing that. So check. See that it does not work. Okay, it does not work because we have an open. So you cannot have the hole and this feature together. All right, so it will not work.
Okay.
All right, so that was the reason. I think because of my experience, I knew that we would not be able to have both features at the simultaneously. Okay, that's why I have created the whole last. And now that I have completed this piece, I will say that maybe let me see if I have the center. Okay, I don't think this is does it show the center? No, there is no axis. Okay, there is no axis in here, so I won't be able to use the whole tool. So the best thing is to use extrude. Okay, the best thing is to go extrude, click on that surface, check, and again we go to no hidden, right click, reference, there we go. And we're gonna place the circle right here with a diameter of 12, and how far is gonna go into this material. We can say 16. Okay, we can say 16 and check. So I'm gonna reverse that and give a depth of 16. There we go. We're back to where we were at. Okay, all right, so this is it. Now I'm gonna show you how to create the mechanical drawing. Okay, put your seatbelt on. So we go to new, and then we click on the drawing, and we give this file name, which is chapter 5-EX1. Okay, EX1, exercise 1, not example. Okay, channel exercise 1, and then we click on empty with format, not just empty with format, browse, click on A size paper. Okay, all right, so everybody's happy, is clear. All right, so now we're gonna bring the two views. Okay, the front views, general. We go to general view, we click on general view under the sketch here. I'm gonna place the front view first, and then I'm gonna right click on this front view, right click, and there is a real tab here called projection. It's called projection view. So that's our projection view. And then I'm gonna go back to general view. I'm gonna say okay. I'm gonna put the isometric. Okay, we wanna put the isometric. And that isometric is just a pictorial sitting on the upper right-hand corner. Now I need to convert the shade to orthographics 2D drawing with no shade. Okay, double click on this view. You go view display, follow environment, hidden. Oh, you always pick hidden. Okay, do not select no hidden. Always hidden. Tangent edges, none. Okay, because we don't want to project line from the edge, okay, or tangent edges, all right? So we don't want to project that because that's an extra solid line that is not, it's against the rule in mechanical drawing. So we go to view display, follow environment, and then after a while you get used to this, okay? You get used to this. So now I have two views, the front view and the right side view. No need to have the top view, okay? We don't need to have the top view because the top view does not really explain anymore about the shape of an object. And if you look at the textbook, for mechanical drawing, they're only showing this view and this view, okay? So we don't need to have that view. So next, you're gonna add center line because we have holes, so we wanted to add center line. So we go annotate, center line, we go to show model annotation. Let me see if I can bring this down.
Professor?
Yes.
I think your screen sharing is still on the 3D model and not on the drawing screen.
Thank you so much. I wish you, because every time I go to do the, I'm still on this, what do they call that? Let me just move this to this here. And you're absolutely right. Because if I go back, this is where we are at, right? Now I have to share a screen again. I'm gonna stop or share, new share, okay? New share, I can just share this here. So can you see it now?
Yes.
Okay, so should I repeat, or you know how to bring these two here?
If you could just go back, that'd be great.
Okay, I can go back, okay? All right, so let me see if I can delete that and everything will go. And then I'm gonna delete this, all right? Can you see everything now? Please let me know because I forgot all about it that I have to have a new share, okay? So
Yeah, we can see it all now. Thank you.
Okay, great, fantastic. So let's do this, my friend. Let's just move this down here so it doesn't interfere with what we are doing. And I'm going to bring one view at that, okay? General view, okay. I'm gonna click on here, click on front, and say, all right. So if you're, and then I'm gonna just click on this front view and click on projection, okay? Projection view, so I'm gonna bring that one. And also, I'm going to bring the isometric and position it. That's isometric position on the upper right-hand corner. If your view is locked, okay, now I won't be able to move it. Right-click and say, this is the leader view. Right-click and say, unlock view movement. It says lock view movement. Now you can move it, okay? So you can move your view to different location. These two views have a fixed relationship, fixed, okay? You should not bring the view one at a time because they don't have a fixed relationship if you bring one at a time. Now, this view, see that? It goes through this. So see that the height matches with the height. You cannot go up and down with the right side view. See that? You cannot go up and down. It goes only left to and right. It goes to the left, it goes to the right. And the leader view, which is the front view that I brought it first, if I move this up, the right side view moves up with it, correct? If I go down, it goes down. So there we go. And then I'm gonna double click. I'm gonna say view display, follow environment, hidden, always click on hidden, tangent edges, none. By default, it's a default, say none. Okay, do the same thing in here. Say view display, follow environment, hidden, tangent edges, none. And we are all ready to go. Now that I have two views, orthographics or 2D drawing, mechanical drawing, I need to add the center line. So I'm gonna go to annotate, show model annotation under here, right here. Just pick the far right symbol, okay, that symbol. And then you click inside this box, okay, there is a box. See, there's a rubber band box. So I got the center line, we say confirm. And then do we have a center line in here? And there is a center line underneath the solid line. It's not needed really, but you see that? There is a center line, there is a rules, okay? If in a coinciding situation, because the solid line and center line, they're coinciding. The rules in mechanical dimensioning, okay? And I used to teach manual drafting back in 80s, okay? 80s, 90s, before computer. I used to teach on the, the drafting board or like architectural drafting classes, mechanical drafting classes. At Mesa College in 1983, I started teaching the drafting that was required for mechanical engineering and aerospace that we needed to train people to learn how to communicate, called engineering graphics communication with the machine shop. So I started teaching drafting classes for mechanical engineering and aerospace. So not architect, because architectural drafting language is different, okay? It has elevation, it has a floor plan, and you have to just design a kitchen or bathroom or the wall and all kinds of stuff. So my area of expertise, knowledge was mechanical drawing. And I knew the alphabet of mechanical drawing from A to Z. So how to create 2D drawing and how to create 3D solid model, or we call it isometric. So there are like hundreds of rules put in the book. We call it a book for dimensioning and tolerancing, and how to add, for example, the features such as center lines, hidden lines, and all that. There's an alphabet of lines. It says if you have in coinciding situation, the solid line and center line, since the solid line takes precedence over the center line, we don't really need to show, we don't need to show the center line. You can delete that, okay? But it's here, this line is coinciding with the solid line. When you project that, we say it's underneath the solid line. You don't need to worry about that. I think the author of this book is showing it, okay? It's showing a center line. It's up to you. You can keep it or you can just remove it. Okay? It doesn't make any difference, all right? So now I'm gonna give dimensioning, okay? There is one way to dimension is, there are two ways. One way is to do manual dimensioning. See that here is a manual dimensioning. If I click on here, that's a radius of 22, right? If I click on this line, it's gonna give me the 95. See that? If I click
Professor?
on, yes.
I don't know. Maybe it's just my computer, but I'm still seeing the 3D image. Is everyone else seeing that, or can anyone else see your drawing?
I'm seeing the whole drawing.
Okay, so Christian, maybe check to see what happened.
Yeah, I'm not sure. I'm gonna end my session and log back in. I'll try that. Thank you.
Fantastic. Just give me, guys, 1 minute. I got a dry mouth, so let me get the water, okay? Just give me 1 second, okay? Wow, without water, we won't be able to function. So anyway, all right, so this is the 2D drawing, and we wanted to dimension it because a drawing without dimension has no value, okay, no value. The people in the machine shop, the machinists would like to see a proper dimensioning so that they can make this part. They can create the solid models for you from the mechanical drawing, because we don't dimension the solid model, we dimension the 2D layout. That's a 2D layout. So if you don't want the manual dimensioning, what you do is you go to show model, and then you click on this symbol here, dimension symbol, and then you click on this surface, for example. You see that? All the dimension that we entered is showing up. So we're gonna go 1, 2, 3, 4, 5, apply. And then I'm gonna click on here, it says 68, we say apply. We're gonna click on this, we say 1, 2, apply. Okay, and then I'm gonna click on the hole, we say yes, apply. And then I'm gonna click on the curve, we say apply. Okay, all right, so that's good enough. Let me just move this to the side a little bit so we have no overlapping dimension in here, okay? So let me just remove this dimension, the manual dimension that I entered before. Now you need to organize it, okay? You need to organize this. So we have this 38, remember the 38 here. Let me move this dimension a little bit lower, and this is 19. Recall that we did the 19, correct? So that's a 19, this is 16, this is 55. Remember, there is a line, extension line. This is extension line, this is dimension line, this is a numerical value with 2 decimal places. See that if you move your cursor close to this here and to this line here, you see that you click on it, and then you have this circle. You pull the circle to the left because you don't want the extension line to overlap with the solid line, okay? You don't want that. So there should be a gap between the object line, this is the object line, and extension line, approximately 1/8 of an inch or 1/16 of an inch, okay? So there is a gap, there is a gap. There is a gap here, all right? So as you can see that there is a tiny bit gap. All right, so beautiful. Is that here? I have to pull it down, okay? I have to pull this down because it's overlapping. See that here? Watch for that, okay? Watch for that. And then now here, I have this diameter, and that diameter, I want the arrow from going inside the circle. I'm gonna flip it, okay? I'm gonna flip the arrow. Let me see if I can, come on, flip the arrow. Just see this here, right there. So it's gonna flip the arrow. and I'm going to move this dimension for clarity to the right, and this is 12. Okay, no problem. Do we have the 12 in there? Do we need that? Because the 12, oh, it's supposed to be on this side, but it doesn't matter, okay? It doesn't matter. And now we have to give it dimension here for the chamfer, right? So let me just use the manual dimensioning. I'm gonna click on this line, control, hold the control down, and then you say this is 64 degrees, okay? So that's a 64. It's a little bit too, I'm gonna show you how to make the font smaller, okay? Just bear with me, okay? Bear with me, I'm gonna show you how to do that. So we have 19, we have 12, 60, oops, 68. And let me just move this a little bit up. Okay, it doesn't matter if the book has in the bottom, you have on top, doesn't matter, okay? So this is 24. Let me move this down. It's a good habit to fix this, okay? Now I need to give a dimension from the center to this edge, which is 34, okay? 34, I don't have it. So I'm gonna use manual dimensioning. I'm gonna click on the center line, hold the control down to select another edge, okay? So that edge, now you can see that this is 34, all right? So we have we position it to the middle clip, and since there is no room in there, let me just move this a little bit lower, okay? I'm gonna move this a little bit to the left so it's visible. We wanna make it visible, okay? All right, so I promised you to show you a couple of things here, okay? Couple of things. One, remember there's a symbol here. It says diameter of 12 and how deep that hole is 16. This is what we do, okay? I'm gonna click on this dimension, and then I'm gonna go to, let's see, dimension text. Let me see if I go to dimension text. I'm going to place my cursor at D, okay? See that at D? And then I'm gonna click on this symbol. It says how deep that is, okay? How deep that is. All right, so you see that I added this symbol. That's a depth. Oops, I have to go back, okay? I have to go back to this because I forgot something. Okay, all right, so let me just, I'm gonna go back to dimension text. I gotta say, I have to give it, deep, so 16 deep, all right, so there we go. Diameter of 12, and this hole is 16 deep. Now, if you wanted to make the dimension smaller, okay, the font size is smaller, I'm gonna show you how to do that. Also, if you do not want the decimal places, so you highlight the entire dimensions, the entire dimension, it turns green, okay? It converts to green, you highlight it, then you go to format. See that on the right-hand side, it says format. It says decimal places. And then you say 0, and instead of 2 decimal places, say 0 decimal places. Now you have 0 decimal places, okay? Does that make sense? All right, so now, if you want to change the size of your dimension, you can just highlight the whole thing. Then you go to File, you go to Prepare, Drawing Properties, okay? Prepare Drawing Properties. And you're gonna say Detail Options, okay? Detail, not the tolerance, ANSI tolerance, no. Change. And then here we have the text height. By default is 0.15625. I'm gonna change it to 16 of an inch, okay? 0.125. Is that 1/8 of an inch is, yeah, that's a 1/4 of an inch. And this is 1/8 of an inch, correct? 1/8 of an inch, all right, so, and then we can say add, and then see that we change the value from default to 0.125. We say apply, and then close, and then close, and now you see your text height is smaller, okay? Smaller, there we go. Now, when you're done with this mechanical dimensioning, or you have the front view, you have the right side views, and everything is there, there is no missing dimensions, and everything has been just moved to the, you know, dimension to the side so that there is no overlapping. Let me see if I can just move this to, let me see, where am I at? It seems like there's something frozen here. All right, so that is, okay, so right there. All right, so you don't want your lead, this is called leader line, okay? This is a leader line. You don't want your leader line to be, you don't want your leader line to be vertical or like that. That is incorrect. You don't want that to be horizontal. That's incorrect. You need to give an angle approximate the eyeball. You have to eyeball it. It's about 45-degree angle with respect to horizontal line, okay? Approximately. That is a proper way of dimensioning, because when you work for a company, they should show your mechanical, because they ask you, can I see a sample of your mechanical drawing? Then they know whether you have knowledge of mechanical dimensioning or not. They look at the people that work on those industries and they are familiar with mechanical drawing, dimensioning, tolerancing, and all that. By looking at it from distance, they can see that whether you are knowledgeable or you're just rookie, you don't know what's going on, and that is uncomfortable. They're gonna feel uncomfortable giving you the job to do this kind of, sensitive, maybe a part for the drones or aircraft or something. They see this person is not really knowledgeable in this area, and we don't have time to train them. So make sure you go and get the training and then you come back here, all right? So please, I'm trying to teach you this so that for one day you're gonna be working for top companies, and as an engineer, you may not really be doing the mechanical drawing, but if the people in a drafting room, if they made a mistake, you can catch that, okay? If you have knowledge, you can catch. But if you don't have the knowledge, then you say, oh, it looks good. That's all you can say. It looks good. But deep down, it doesn't look good, okay? And that's what it is. So next, if I want to put a note in here, so say who did this, we said drawn by, capital letters, okay? And put your name and last name, please, okay? Put your name and last name. And then you click somewhere here, you go to the next one, you say note, and then you're gonna say title, then you give the title. For example, I don't know the title, but we're gonna say this is chapter 5, CH5-EX1, okay, EX1. I hope you're not getting tired, okay? Because I'm having fun, I hope you're having fun. And then we're gonna give the, oops. I hope this is not going to, all right, so let me just note, I'm gonna put this ENGE 151, and it's a Mesa College. So we got Mesa College, and then we're gonna give a date, okay? Let me just go here, say we have a date, today's date is 6/25, 2020, okay, with Balborough Walter, 2020. Okay, that was a nice show. For at least 20 some years I watched her show called 2020. So and this is another note, maybe is important. We say scale. Okay, we want to tell the machinist the scale is 1=1, okay? Because those numbers that you see here, they're the actual dimensions that they're gonna use to make this product, okay? This part, solid model. Now, if you wanna look at the blueprints, you say File, Print Preview. You can see that now, this is your blueprint. See that? It looks blue, right? Blue. So that's a nice dimensioning. Center line, hidden line. This is the hidden line for this hole. That's a hidden line. So that's a standard US system of drafting mechanical drawing. And there we go. And you have the title block. People look at your print. They say this is professional. It looks really fantastic. No mistakes. And we are ready to make this part, okay? All right, so whether they wanted to do it manually, make the parts in this, or they can program it, convert this Creo to CNC machine. You have to learn how to operate the CNC and you can make this part, okay? All right, so Any questions?
Real quick, how did you put the drilling dimension in there where it says circumference 12, drill 16?
Okay, this is here. I'm going to show you how to do that, okay? Let me go back to my drawing here. I'm going to click on it, okay, click, and then go to dimension text, okay, dimension text, and it's going to open this window. Do you see this window? Yes. You know where it says at D?
Yep, I see it. We're good.
Okay, then you just put your cursor after D, okay, put your cursor here, and then you can just, okay, let me just move this, and then you say, this is the symbol that we want, yes, and then we want to type what, 60, and there we go. Life is beautiful, look at that.
Perfect, thanks.
Okay.
Also, I noticed sometimes my hidden lines, oh, you know what? Never mind. I guess the hidden lines are solid.